And I'm live. That is pretty cool. Today is 20th of November 2025, Thursday. Shit, I had to look up Thursday. And with that, let's begin. From Starting from today, we will be building a Redis in-memory database, Redis-like database in Go. And I only have a basic understanding or some understanding of Go since I started learning Go a few days ago. And what is this? Okay. So we need a plan. First of all, the advantage is that I have built a Redis-like system in a previous stream, so that is good. And there are some things that we would need before the whole client server REST API thing. Okay, this is not a REST API, at least the protocol that I used in the last Redis thing. It was not RESTful. But now, yeah, now also would not be RESTful. There are some things that we would need. How to send requests, how to create, okay, why is this in the middle? How to create sockets in Go or how to work with sockets in Go. And not that I think that would be about 50 or 60% of the main thing. And yes, that would be a very main thing that we would need, one of the major things. And when we do know that, we will also need to implement our protocol, implement our protocol, which we will be using, and which would be a very like simple protocol, nothing special. That is cool. Yep, implementing our protocol, and what else we would need? Yes, we will also see what the protocol is that we will be implementing, and then we would use event loop. We would implement our event loop, for which we do need a few things. Polling, we would have to use polling in the event loop to determine which operations are doable currently, like which sockets we want to read from or write to, or maybe accept a new connection, and which of them we can do currently in a non-blocking manner. And then we will do our read and write on those sockets only. And then let's see how to work with sockets in Go. That would be nice. Hello, always newbie. Shit, you have been here before with a horse. It's nice. How to work with sockets in Go. Let's see. And also 72 into 89, that would be 90. 90 into 72, 6,300 plus 180, 6,480, 6,480 minus 72, 6,308, I think. 6,408. Okay, my bad. Let's create a new project and go. Let's make there. Yeah, make there. We will write a new project. Wait, I think yeah, projects. Okay. Redis in Go, Redis in Go, and Go mod init. Or before initializing anything, we will create a repository on GitHub for this new repository. Let's just simply Redis in Go and nothing. And let's also add a license. Like, why not? But shit, we cannot any longer. Now, uh, git clone dps colon slash slash github.com slash Redis Go. L. Okay, that is fine. Move. Okay, RM Redis Go. RM RF Redis Go. And now git clone this thing here. CD Redis main branch. And now go mod init Redis Go. And git state git add this thing. Git add git uh, commit initialize git push. And I okay, I also want to tinker around with the git thing. And if we see here, git remote origin. Origin is the name by or the variable you could think by which we are referring to this remote repository. So let's see how to see remote repository link in git remote v. Yeah, this is the thing. And how can we change remote repository name in git? How can we change v to c? Set URL, the old one, and the new, no, we do not want to set the URL. Git remote set, what are the things? Head branches URL. No, we do not want to change the URL, or we can just add a new thing. Git remote add, let's say GitHub. We will call this GitHub. Git remote add GitHub https colon slash slash github.com slash the place where the repository is Redis Go. And that is cool. Git remote we have GitHub here. And now if I do some change like git ignore and save this git ignore file, git status, git add this current file, and git commit added ignore and git push github main shit git push github main, and we will see the thing reflected here. We do have the git ignore here. So we have changed the name from origin to something else. Hello, Archit Mishra, how are you? Read a second? Yep. Try something new. Okay, yes, I thought about it and try something new. First, I want to get used to writing things in Go, and I have done Redis. So I think Redis is the known thing here, and I would also be like understanding how to work with sockets in Go, and Go is the thing that is the unknown in this whole project, and I have idea about how to work with sockets in general. So I would be revising the sockets and I would be getting used to Go. Try with a simple HTTP FTP server. Okay, yes, I would like to do FTP server, which would work or over LAN. Shouldn't have started with that. Should have started with that itself. Huh? Same thing for each new language again and again is pretty inefficient. Uh, I mean, I guess I can do this in a couple of days, and then I can do what I want to. Like, I want to do this first, so I'll do this, and then I have a plan. I would like to make BitTorrent in Go. Like, that would be cool because I don't know how BitTorrent works, so that would be cool. Yes, after this, that would be BitTorrent. And with that, let's just begin. How to work with sockets in Go. Let's go. A complete guide to sockets in Go. And wait, how would that be Like Rust again. Shit, Rust is cool. You can do that. And memory management, I think it is hyped up to be more complicated than it is. It is just three rules, and that's it. And also, like, how would it be inefficient? Like, working how same things happen in different languages, I think gives a more better understanding of how what those things are from an abstracted point of view, but didn't go with the rest book. Instead, it started with porting one of my projects and learning things on the go. Shit, pun intended. I feel like that is the better learning for me. Okay, not the book, but writing things on the go. Shit, I guess we have a different mindset for learning things. Like most of the C, like languages have pretty much the same syntax for loops, conditions, etc. That is, yes, that is cool. Mm, yeah, and yes, how things happen. Socket programming is a way of connecting two nodes on communication with each other. To communicate with each other, that is, yes, cool, makes sense. One socket node listens on a particular port at a IP. Wait. Yeah, straight to the thing. Net dot listen. Okay, the problem that I have with like looking, so wasting half an hour on learning again is just a waste of time. Okay, like when I look at this line, I want to understand like what this thing is, and my belief of that, like what the way for understanding this thing is reading the thing. And like how am I, so I should have just 15 minutes. It should have been just 15 minutes to look up. Okay, think you are right, but yes, that is the main thing to get things done, but also understand the things, and we can directly look up what I want to look up. But I think that when you actually go and read these things and go through things again, then you get a better, more versatile understanding, I guess. Okay, understanding TCP UDP. Yes, reliability, ordering, speed in TCP, and net package. Yes, this thing. Should I actually haven't done this? Like, yet you took 3 to 4 days just relearning those things again. Read the comment above the last one. Should it should be max to max 5 minimum things, like you already know about structs, functions, pointers, etc. Only things you need was how to write it in Go syntax, but not just the syntax is very surface level. Like things happen differently in different languages. Like in C, we can tell specifically, I want this thing to go on to the heap, or I want this to go on the stack. But on Go, it is the compiler who decides where to put stuff. So that sort of things. Okay, let's try this approach, like what gives, and I can just look up specifically what I want. Yeah, how can I create a socket in Go? Creating a socket in Go is pleasantly bare bones, no magic hidden. High level net package is what 99% of the time TCP UDP client servers. Okay, syscalls 2, and this Unix package. This is where you get raw POSIX. We don't need POSIX thing just yet. Raw sockets. High level net package. import the net package, and we do this. We can have the go land and shit. Yes, I'm learning a lot from you. That is nice. So how would that have stopped you or hindered you from practically writing it? Yeah, I know that it is important, but giving that much time just to learn about structs, functions, references, nah, read the docs for that. In They are kind of a substitute for the docs. Okay, yes, there are things that I can improve. Of course, there are things that I can improve in my method of learning. And yeah, sure, I guess I'm biased from the official documentation. The docs for this package is good. Okay, that is nice. Thank you for that. Like, yeah, I still have the bad mindset which I want to change. So, okay, that is nice. That is nice. Thank you for the advice. That is cool. It is cool, yes. So, okay, in the boot.dev course for the Go, it is for beginners. And since I do have some basic understanding of how other things happen, so instead of seeing, going through this whole thing and seeing how the same things happen, how to make a loop or other things in Go, I can go to the docs and read from there since that is accessible to me. Look, wait, the docs one was for net HTTP package. Right. Uh, yep. And I guess shit. Yes, you are right. You're right. If I just stick to this, like whenever I want to learn a new things and I just go to the most introductory exposure to that new thing, even though I have previous experience, I'm not taking leverage of that previous experience, right? Yes, at a fundamental program, it would have been understandable. Yes, 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 you are right. You are right. I was just being a bitch. Yes, you are like completely right. And if I keep on doing this, like give me the most basic introduction to Go for learning Go, then I will not improve because I can over time get used to reading documentation, right? And yes, that's what I should do. Mm, yeah, an introduction can be taken by a beginner, but then how can I leverage the things that I already know? So yes, you are correct. Thank you for that. Thank you for that. Shit, you are, and you are not even in college, right? You are in a school. Arjit Mishra. Shit, that, okay, that is a shit. Okay, we can specifically say we want HTTP. Okay, yes, I have to improve my methods of learning new things. Yeah, yeah. If you pay to write something for a C sharp code base, then you would spend a week just learning the basics again. Yeah, you are correct. Since I do know that C sharp is converts into bytecode, I think, just like Java, and I do know other basic programming things, then I can extrapolate and make judgments of how same things would happen in C sharp and then learn from errors. Most thing in programming is the most thing in programming. It is in other fields too, but it is especially true for programming. When did you start learning programming? I guess 2 years ago. And yes, I've stopped programming and started programming, but I started programming very, very seriously this year. Yeah, with competitive programming. And before that, I've just yes, since I started the YouTube channel, I guess with assembly, and that was yeah, that was like main biggest step. And now, okay, I still have the bad mindset pretty early. We're learning pretty fast. And okay, thank you for that. Shit. And how shit am I correct about wrong about this that you are in school? Shit, I think you said you are in school. That is crazy. Yeah, I still have the mindset of looking for tutorials on a thing for a thing that I want to learn. So that is cool. That is cool. That is cool. We'll keep in. Yeah, that's cool. Okay. I'm like stopping on this topic and talking about this again and again because this is a fundamental shift in my point of view. Lol, same here. I too had to leave programming. My parents said that now you are in ninth, focus on study. Shit. Shit. Yeah, I mean, not exactly school, but not in college either. Drop year. Shit. You are supposed to be studying for GE, I guess. Shit. You already know quite a bit, so I don't think you have to worry about getting a job. You will have like 4 years in college when no one will ask you for any results. So that is cool. Okay. And net package, we can literally go to the documentation. Packages, implementation, net. Yep. And listen. Okay, let's listen. HTTP, no. Okay. So where is net? Net, let's go. Wait, what am I even looking for here? Yeah, this takes in two things like the protocol and the port. Okay, and ln is something. Let's write this and we can use jump to definition and stuff for documentation. Cd go to um, stuff, go socket, go sockets, uh, go mod init sockets main.go package main func main ln and error equals net dot shit link listen. Okay, listen to this. This says TCP and this takes this as a string. So that is something. And it's I will copy your idea about creating a copy function, a check function. I started learning programming in sixth, then got stagnated in seventh. Then my elder brother told me about these websites like Codeforce and CodeChef. Lol, I remember I liked the UI of CF. Shit, it is still kind of uh, old school UI. I went with CC LOL with code shifts. That was just a childish brain thing to do. And now I get embarrassed thinking about this shit. CC is fine. Working with sockets and other connection related things are very easy in Go. In fact, that is one of the main spaces Go is used and the biggest selling point of Go. Go, yeah, I have also heard that, yeah, servers for Go are cool. Okay, listen TCP and this and check the same thing. You said yesterday, and if E is not equal to nil, then panic with the error. And okay, listen announces on the local network address and shit. Yes, shit. In the back of my head, the same thing is going on again and again. And substituting tutorials with documentation is actually a pretty cool idea. pkg.go. The network must be TCP, TCP4, TCP6. Okay, Unix or this, and then This takes in a network and an address and returns net.listener, which is something. And then wait, can we go to definition of this thing, net.listener? That would be crazy. No, I cannot move there. Yeah. For TCP networks, if the host in the address parameter is empty, host in the address parameter is empty. Okay. Or a literal unspecified IP address, listens on all available unicast and any cast IP addresses of the local system. Okay. To only use IPv4, use network TCP4. To only use IPv4. Okay, why this is not even asking for IP, like which IP version we are going to use. Use TCP. Okay, shit. Oh, yeah, it asks for it in TCP form, TCP4 or 6. This address can be this address can use a host name, but this is not recommended because it will create a listener for at most. Okay, but this address can use a host name. This address can use a host name. Okay, but this is not recommended. Host name as in like DNS host name particularly, and by address they mean the address is string host name, but this is not recommended because it will create a listener for at most one of the host's IP addresses if the port in the address parameter is 0, as in this thing, then it will automatically choose in. Okay, check error. And what is the type of LN? LN is listener type, whatever that means. Net dot listener. Listener. Yep, listener is the interface which has accept, close, and adder. Returns adder of the listener's network address. And what do they mean by address? If like I am creating a socket locally, then shouldn't the address be known? The address would be the address of my local computer, the IP address. Like, how can I change it to anything else? Okay, you can open the docs for net package. Everything is written in detail with the signature of the function and everything. It might get hard reading just from Go to definition in NeoVim. The website docs would give you a reference links you can read and understand. Let's go. This is the documentation, I guess. This is for HTTP. Okay, it does work. Going to network package documentation. Uh, Go net package docs. Okay, that is the thing. Net package. Okay, like the function that we are calling is listener. Villain, listener type accept, close, and adder, and these are links. Okay, that is cool. That is cool. That is cool. Type listener and wait. Yes, listener listen. Listen method should be around the top somewhere. Listen IP, nope. Listen address and network. Shit, this might actually be it. Listen config LC. No, this is not that. Network and address. Yep, yep. That is the function. Listen function. Wait. No, this is something else. This is something else. This is the one. But we also have a file listener. Okay, that is a file listener. This is the listener that we are using. It returns a listener and an error listen announces. And yes, I'm like not doing this in the most efficient way possible, but I guess over time, yeah, figure out. This is returning us a listener and error. We are checking for error and what can we do with the listener, for which we can go here, defer listen dot close, close at the end, makes sense. And then for connection error, we accept a connection. Okay, and then print if there is an error and continue. Otherwise, go handle. Okay, go hand go. Okay, what is go? Go is like shit. Is this creating a new thread? Concurrency thread. What is go? Um, for calling a function in Go. Let's see. Okay, calling a function without Go. The Go keyword is used to execute a function call in a new independent executing thread of control known as Go routine. Okay, this is a new thing, Go routine. This is a core feature of Go's concurrency model, calling a function without Go. When you call a function without Go, it executes synchronously. The program waits for my function to complete, and then the main thread runs, or the program which we are calling without the Go runs on the main thread. Okay, calling a function with Go. When you call Go my function, the my function call is launched in a no new Go routine. This means concurrency. This function begins executing concurrently with the rest of your program. The main program flow does not wait for the Go routine. So is this creating a new thread? And okay, what is this doing? Lightweight. Go routines are very lightweight compared to traditional operating system threads. Shit. So is this creating thread on the language level, allowing you to easily create thousands or even millions of them without significant overhead? Shit, that is crazy. If that is what is happening, then we can put every new client connection on a new Go routine and we would not face any problems, and we don't even need a event loop here. So shit, we created event loop in the last Redis using C++ because creating a new thread and executing and handling threads creates a quite a bit of overhead. So we were trying to save that. That is why we created event loop, but these are even lightweight, more lightweight than threads even. So that is cool. Communication. Go routines often communicate with each main program or other Go routines using channels, a built-in mechanism for safe and synchronized data exchange. Long-running task. Sleep this thing and then a long-running task. So this is simulating long-running task. Go this. Main program executes. Sleep this. Give the Go routine some time and then main program executes. So that is cool. We just have to do this. Go. Instead of normally calling the function, we just have to put go before the function and that creates a Go routine. So that is cool. That is cool. Okay, if there was error, then we will panic. Otherwise, we will we will accept. Yep. And also defer the close and get the connection, handle connection. What is connection? Type is net dot connection, defer close the connection at the end, and write. We can just give stuff like this. That is cool. We don't have to see whether we have written everything or not and how much bytes we have written. Don't have to take care of that in Go, it seems. That is cool. Okay. Defer ln dot close and for true, for just true, right? Yeah. For this true, this will keep on running and we will get a new connection. Connection would be ln dot accept. It returns two values, okay. And an error, check error, and then go handle. We will write a handler function handle connection type net dot connection net dot con, okay, with a capital C. Go handle con, and in the connection we will do con dot what other function we can print something. Let's write, we will write, yes, we will write to the connection. We will byte convert this thing on the right into array of bytes, and this this is a message from the this is a message from the server. That is nice. This is and no, we don't want to check, we do not want to panic if error is not equal to nil. If there is some error, then we will do empty dot println e error. I think yes, we can do that and continue. Otherwise, handle the go routine on a handle this connection on a new go routine. That is cool. And also defer connection dot close. That is cool. Okay, so we have the client side, we have the clients, we have the server side. We need to implement the client side. Go run dot cool. This is running. Interrupted. After this point, print ln server is listening. Let's go. Okay, and that is cool. Server client move go.mod and main.go to the server and go to and let's start debug state 2500 minus 52,450. I think that better be correct. Okay, that is correct. And shit, okay, 55 into 23 5 20 100 118 115 115 1150 1150 1250 1265 1265. Should I actually wanted to create a new window like this and 21 into this 400, yes, 430 4300 4300 plus 23 4323 22 20 yes 430 453. I might just mess this up. Hello, that is go routine. What the fuck is the chat not instantaneous? Shit, something is bad. The YouTube shit 483 483. Yeah. And that reminds me, I still don't know the difference between go routines and coroutines. Shit. core routines are functions, and we would have to see. Yeah, more or less like that. Go routines are like Java's virtual thread. Shit. Each Go routine takes only a few hundred kilobytes to MB of memory. Why to implement that? Like just use curl to check the server. Is that checksum for? It is not checksum. It is just, yeah, it is there so that I don't become a retard and cannot do basic maths. Shit. I can use yeah. Uh, yeah. Schema. Attach target 0. Yes. Shit. Rename window. Nope. 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 Just how do I close this pane? Yeah, kill pane. Cool. And curl. I can use curl. That is true. Curl sends. Shit. Let's see. Let's see. Okay. Go run this and shit. 63 1800 1860 1860 plus 186 1960 plus 86 960 plus 86 2000 plus 46 2046 I think. Yes, okay. Correct. Localhost shared https colon slash slash localhost. Shit, how do I even do this? To send request to localhost and curl or uh and curl option localhost port. Shit, yes, that is what I did. But HTTP is the bad part. It's we are not using HTTP. We are sending a request on a socket. Yes, my bad. Forward to basic terminal commands already. Yeah. Wait, can I just do this? Nah. For a socket. How can I send a request to a socket using curl? Shit, I don't actually know how to use curl. Unix socket and path to socket dot localhost HTTP. But we are not using HTTP here. Uh, oh, net dot listen on the client side. Net dot dial is what we use. Can ping. Yeah, ping is I guess something we can use. Ping. How can I ping with local socket on TCP? TCP. Shit, no. Unix socket. cannot use curl here. Yes, you can use curl, but if only speaking HTTP, it is not speaking HTTP. TCP, write this thing, accept a connection, and write this. Okay. So the curl would send a HTTP formatted text or byte stream to my server. My server will not read anything. It will just respond with this. And if I do respond with this HTTP header and this simple body, then curl will show me this. But if I send just what I'm sending right now, just a text hello without the HTTP formatting, let's see, like this, uh, colon slash slash, yeah, colon slash slash, localhost, colon fp received, yeah, curl received HTTP9, but not allowed. What does that mean? We are not even sending HTTP stuff. Main.go, and this localhost port would do, I think that's all, curl TCP request. Yeah, curl seems to be just using HTTP. So we'll have to use this thing. This is how we specify the header. Okay, this is the header part, and then return carriage and new line for the new line. Then again a return carriage. Shit, somehow. And new line. Okay, that is empty line. So this return carriage and new line is for ending the current header line, and then return carriage and a new line for, I guess we have to put a empty line there and then hello. Let's return with this. We just want to check if this thing is working. HTTP, what is the format? HTTP slash 1.1 200 okay. 1.1 okay. Return carriage, new line, return carriage, new line, and then hello. Go run this thing. Service. Shit. I created a new thing. Yeah, curl the above thing. Hello, we do get hello, so it is working. Requi failure. Collection connection reset by peer, because yeah, we are resetting the connection. We are not doing anything else. Yeah, that is working. Let's also add a new line at the end. And let's do something so that we don't see this. I think we can add a wait, because this thing is, wait, we saw the hello later, but we saw the connection closed by a peer first and then the hello. Okay, why that peculiar order? So this function ran first and then this thing was handled by the kernel. Let's add a sleep. How do we add a sleep? Sleep in Go, time.sleep function in Go, time.sleep. And what does this take? Duration, time.duration. Okay, sleep in Go. Let's see. Time.second, 8 seconds. Okay. Let's make this sleep for 4 seconds. Go run this and curl this. Okay, we did see the hello, and then we will see connection closed by peer. Okay, that is nice. So why was this order here? I think this was because the connection was closed. Who is actually maintaining the connection? And okay, there are two unknown things here. who is actually maintaining the connection, and that would be the operating system kernel who is managing the connection. And then about the go thread, where is the thread actually working, like, and shit, this, yes, we can say that the connection is handled by the operating system, because yeah, different languages have their own interfaces for creating a socket, but the socket itself is handled by the operating system. The operating system knows about the socket. But if that is the case, and if we write something to the socket and then we close the connection from the programming language side, and it is the kernel who is making sure, since this is TCP, the kernel is making sure that everything that has been sent actually goes to the client. And even though we might stop our connection from the programming language side, the kernel will make sure that everything goes to the client, even though we have stopped the connection from our side. Okay, but if that is the case, then how would it appear on the client's point of view? Because the client is still getting data. And just this thing, why did it say that the connection is closed and then showed us what the connection is? I guess this might be just a random order of things and could have gone any which way. Go run dot, and we are running. Yeah, now we are seeing hello first, and then we are seeing the connection is closed. So yeah, that would be the normal expected behavior. Okay, that is cool. Our server is able to listen to things. And now, what do I want? Shit, I guess we can just start implementing the protocol. How to create sockets. That is just how we create sockets in Go. We don't have to do anything special. Main.go. Yeah, using net main.go, we can just create a socket. We can write to a socket, and this is our listening socket, ln. We are just calling it ln. This is our listening socket, in which on which we are accepting connections and we are listening to them, and whenever we do get a new connection, we create a go routine which handles the connection. And that is good enough. That is good enough. Now we can implement our own protocol onto this. That is cool. Okay. Project cd Redis in Go list server dot go package main func main ln, and error will be created from the net package dot listen for a TCP connection on port 8080. A check function check taken an error, just cool. And if e is not equal to nil, then panic with the error. That is cool, and we have our listening socket. Check for error after creating the listening socket. That is nice. This is like much better than C, much easier interface than C, and I think the speed is comparable. And this layer is the same, because yes, we are getting a bare TCP socket without HTTP or anything. That is cool. And we could even get a HTTP socket if we wanted to. Like sockets are not HTTP or something. We implement on top of a socket whatever we want. Client would get data, but okay. Client would get data, but you wouldn't be able to connect again. Yes. because from our side we have closed the connection, it shows that the server is closed. Okay, I cannot understand what you mean to ask. My bad. You define the full address to, instead of just saying ATT, you can type host and then port. And yes, about this part, it makes sense. Like we want to say start listening on this on this port, but why do we have to say start listening on this address? Like what is the need to provide an address? Because the program knows on which computer it is running. Why does it want to know which address? Because that computer has one address, only one IP address. So yeah, that is one thing which I don't want to look up just now. Let's defer ln dot close the connection when this function ends. Okay. Then an infinite for loop, and in here we will get a new connection with some error, ln dot accept, and if error is not equal to nil, if there is no error, then just continue, and otherwise handle the error, handle the error. And yeah, which I want to put into a new file, a different file. Handler.go. Package, not main, shared. Okay, that one was package main. So I also don't understand completely the package thing that is going on. Package, Redis, go. Why the error? Func handler or package handler doesn't, it does take in something that is connection in net dot connection thing, and yeah, defer connection dot close the connection at the end, and yes, close the connection at the end, and connection dot we can write and we can read if we want to. That is cool. We will write for again testing purposes http 1.1. We have to give yeah, hyphen, and then 200 error code. Okay, return carriage new line, return carriage new line, and then our message in byte, uh, this thing into byte. And here, okay, I think we can just call the handler here. Yeah, handler, give it the connection. That is cool. And we can even move this function into a helper function, so into a helper file or something. Yeah, go run dot and set pmax target 0. Okay, we have this, that is nice. cd Redis go, okay, and running, that is cool. And we can do curl att and hello, that is nice, we got hello. That is cool. Okay, not here, but if you are on a server, you might want to see the files which have the same package can share the functions without importing them explicitly. They can work as if they belong to the same file. The files should be in the same directory though. Okay, like suppose if I have some project and I have created a new directory inside it, right, and then use the package used the package project2, then I want to import the functions from that into my main project, which is in the okay shit, you had to take a space, a dramatic pause, root dir, which are in the root dir, into my main project, which is in the root dir, and inside your root dir you have another directory in which you have the other thing, shit, sorry, package two. Okay, then I would need to explicitly add an import package importing this. Okay, that makes sense. That makes sense. That makes sense. They belong to the same package, and we are calling our package main. So we are calling our package main, which we could name anything else. Should and I did do some things with this on the first day of learning Go. I don't remember. Okay, this is working. So that is cool. That is cool. And projects Redis go and in server.go go.mod redis.go, that is the name of the module, and inside a module you can have different packages. Go.mod, wait, expected main package. In this module this is the main package. Okay, in this module this is the main package, and in helper if we call this uh redis expected package mean, why would you expect package main? Mm, okay, go packages and modules from the documentation. Shit. Code implementation, go package main. Okay, code organization and reusability. If they belong to the same package, we can import them, and it feels like as if they are in the same directory or same file. Naming anything else would make it a library and wouldn't build to an executable, but I can import them to my main package and then execute them. Only the main package are built as an executable. Okay, that is correct. That makes sense. And hello, I should think, how are you? But yeah, that does make sense. But I should be able to, I think, import library packages and Golang from ground up. I think I don't understand packages in any languages. Yeah, and the basic idea that I have is there are executable packages and library packages. We import library into the executable, and that is it. We build the executable, which includes these library packages, some of them, and this is the uh, main package, which is an executable. And when we build this, we import some things from the library and we build all them also, if they are like statically linked. Shit, I think I've seen this dog. Whether you are an expert Golang developer or just starting out, packages with Golang, initially I struggle with these two concepts, package and module, thrown around a lot. You have lot, or you have at least come across them in some reading material. Initially I struggle with these two concepts with my not with regards to what their definitions are, but what they mean for the ecosystem you will find yourself working in while writing programs in Go. In this piece, we will talk a little bit about more packages and okay, packages. A package is a file or group of files. Okay, yes, package is a file. When we say package main, this is a file or a group of files with a namespace and some code or related code. Okay, okay. This means that a package could live in a file such as math.go or across multiple files such as add.go, subtract.go, multiply.go. This would this would many files this would many files, or the singular file would be in the namespace, whatever the namespace we give for the package. That makes sense. So from the developer's point of view, they are in different files, but from the compiler's point of view, they are in the same file, and yeah, they are in the same namespace, so we can call each other. A package will have a surrounding directory like so. The surrounding directory for math is math, or math when these things are divided. Okay, the content of math.go may look something like this: package name, then function, then some function, then some function. Okay, takes in a bunch of numbers, sum equals 0, for number in numbers. This is a slice. Subtraction takes just two numbers, multiply takes a list of numbers. If we decided to split this math package into multiple files, we can make three files: add, subtract, multiple. This for add the add function in this file, package math in the subtract file, and in the math file. In the multiply file, we add the definition of the multiply function. Looking at all these three surrounding files, you may have already noticed common denominator. They all share the same package namespace main. Okay, so whatever I write here, they should go in this package namespace, in this namespace. Okay, okay, that is cool. Of course, you will likely never find anyone doing something like this unless they are splitting very large files into multiple files. It is essential to understand this concept of the shared namespace for what we will discuss next. If we call this and redis.go in the helper.go, why is it expecting redis.go? That is the name of the module. Module might have multiple packages. That is fine. Module might have multiple packages. That is fine. And server, we are able to call the handler. That is something. So do we have to create a new directory for these packages? Let's see. Exported and local. Yo, if you want to make another package and import it into the main, then create a new directory in your project. That makes sense. Okay, then you can write whatever you want in it and then import it in your main project. Why making it again? Getting used to Go syntax and stuff. Hello, you still remember things in this project or forgot? Yeah, I think I kind of remember stuff. But we don't have to make the main learning thing in the last project was the event loop, and we don't have to write the event loop here. But for scientific purposes, I will write the event loop here also in Go, but we don't actually have to because there are Go routines which are faster than normal threads. That is good. I'm feeling you are gonna miss some of the unread comments, thinking you have already read it. Yes, because of many messages are there. Yes, yeah, it happens with me too. Like I cannot blindly remember what all I did. When I see the code, I get it. Yeah, sure. Yes, makes sense. And reading someone else's code is, I think, a very personal thing. You can just look at how that other person sees the world, and that is like very, very personal thing. And yeah, reading your code exactly tells you what you had in your mind, and that is just crazy. The idea behind writing packages in Golang is to create modularized pieces of code that can be stored. Okay, wait. Math import FMT. FMT is a module. Shit, we shit. This is the same thing. Uh, you said that we have to create new directories in our package to um do this to create new packages, and this is what we have here. We have multiple directories. Shit, literally, we have multiple directories which have their own implementation of stuff, and that is cool. Let's go to OS, and there must be something mod.go, like equivalent to go.mod. Go.mod, it was in week, but should also be here somewhere. Go.mod. Okay, go.mod is not here. It was in week. It is in the week thing. This says the name of the module is standard. Okay, everything here is in standard. Require this and this. Require this and this. Golang.org. We are requiring things from the internet somehow. Okay. Package mat multiply import maths. Where did we go? Looking at all this illustrates about the two functions. Mm, Directory name helper and helper.go. Okay, that does work. That works. And we can have our function from this helper, which is not even doing anything. Package. Now, what is the problem with this? Found packages in main use. Okay. Net import net, and we can go to our main file server.go, and check should have been here. It is not. It makes sense. This is in the main package. Okay. Server.go connection declared but not used. And let's say handler take from the connection. What is handler? Nice question. Import dot slash helper. Go. Do we How do I import things? Package import fmt import maths. So this guy is importing maths. Just import maths. Uh, okay. How? Well, let's read. Right. To get all three resulting files, you may have already noticed the common denominator. They all share the name math namespace. Of course, you will likely never find anyone doing something like this, and they are splitting very large files into multiple files. It is essentially we just read this, exported and local function slash methods. We can Every package can have their own methods onto some structures. That is nice. The idea behind writing packages in Go is to create modularized pieces of codes that can be shared across your projects or with other developers for use in their own projects. Way to Golang. I love generous nature. Okay, now for this to happen and for it to happen securely, we may want to expose some parts of our code as external APIs to be consumed further down the line, as well as keeping some aspects of the package more hidden and not so accessible. Some languages export provide constructs like public, private, protected to help with this, but in Golang, the concept of public and private APIs are implemented from the way. Shit. Yes. I think it was. This thing is capital. Yeah, we have to do something here also. And capital. Yo. Uh, so much time explaining the naming convention of Go in it. With shit. Shit. That is very sad. Some beef with you. Yes, you do have some beef. I took think so. Yeah, I do think so. Yeah, just randomly decides to not show my comments. Just I guess if I change this now, maybe it is okay. Requiring from the internet, but ah, requiring from the internet, and we also have requiring from the internet in Rust somehow. So it, yeah, somehow. Now for this to happen and for it to happen securely, I think I'm moving too fast and not comprehending properly, because yeah, I do not want to come back to the same things again and again. Now for this to happen and for it to happen securely, other languages have public and private things, but with Go, the concept of private and public APIs are implied from the way we name our functions, methods, and properties. Let's look at an example like this. Here in package, multiply and multiply, just their name, capitalization is a different thing. This one also is internally calling this function. That is cool. Looking at the illustration above, we have two functions named identically, which with one difference. One is lowercase to multiply and the other starts with a capital letter M. This subtle difference is the distinction between a local and an exported function in Golang. You can go ahead and guess which is which. You may, okay, laughing emoji, you may get it right from the way they are structured, but nonetheless, in Go, when you name something in full lowercase, it is localized and cannot be accessed outside of this package. Remember what a package is. Take another look. Package is a namespace in which we have different functions which are treated as if they are in the same file. On the other hand, anything that starts with a capital letter can be accessed from within and outside of the package where it was defined and declared. Okay, it can be accessed outside the package if the name starts with a capital letter. So if we published our package today, we will look at publishing packages shortly. Okay, we can import this package math and access widely. Where are we importing this package math? How? Attempting to access multiply will definitely throw an error. Why do I have like, why do we have two main functions here? Prints this, but this one prints error because math.multiply this thing. I think we have to do uh, mod init. So mod init, we have to create a module here. Go mod init helper. Helper. Go.mod. Name of the module is helper, which has a package named helper. And okay, but we cannot import this here. Do we have to tell the go.mod thing to require? Should we? Okay, that is fine. That is fine. That is fine. And what is the problem with this one? Goal list initialization failed. Redis go.mod usage module path 1.1.3. Wait, this is just a warning. Initialization failed. Go.mod. Here the version is. This is inside the helper 1.1254, and here 1254, the same thing. Module slash path. So module slash path. Okay, now I have a specific question in my head. Also, one of the quirkiness I hate about it. Shit, let's understand it. I have a. Okay, first let's explain to ChatGPT. Module in Go fully is a full module of is a full yeah is a full fledged source code for a project. It could be an executable or a library. It could be an executable or a library or both, and a module internally has packages, and it can have only one main package, which is executable, and can have multiple library library packages which can be imported each other, and the main package files which belong to the same package are treated as if the functions defined in them are in the same file and in the same file, and at a and in a directory can have only one package. Okay, let's move with that. Few points need tightening. Go module is a version control of packages, collection of packages, nothing more, nothing less. Okay, collection of packages makes sense. It is not inherently source code for a project. Yeah, we can compile it and can contain executable programs for main library, non-main packages, yes, or both. A module is simply one repo, but technically doesn't have to be. Think of a module as an outside boundary which has packages and stuff. A package is the actual building block of your Go source code. Zero or more main packages. Multiple main packages are absolutely allowed. Huh? Each main package produces a separate executable. Shit, we can have multiple executables in the same module. Example module structure. And this go.mod, defining our module. And inside this, we can have a packages directory which has some things, and libraries. Server has its own main.go, and migrate has its own main.go. Okay, okay, and they are in the same different directory. Okay, this is totally valid, and it can have only one. Okay, that is wrong, I admit. A module can have as many main packages as you want, as long as they live in different directories, and so that they will be able to share the same libraries. Yes. Okay, okay, okay. In a directory we can only have one package. Yes, a single directory equals a single package name line across all files in it. This rule is ironclad. Files in the same package behave as if they are one file. Yes, this is exactly the mental model. Same namespace, same imports, same visibility rules, functions, and type auto visible across files. Go does not care how you split files as long as they share the same package name. Okay, somebody here's the nonsense. Correct. Screenshot. A module is a version control. A module may contain multiple library packages, multiple main packages, so we can write our client and server both in the same module as different packages. All .go files in a directory with the R belong to the same package. A main package creates a binary. Module is not automatically a project, though it often serves that role. A module is not directly automatically a project. Okay, so now library in a module and then import it into my main package. Let's keep it practical. Creating our module. How do we create? Yes, go mod in it. Okay, we have our mod. How to create a library package, not a module. Create a library package. Yes. In our main things, we have a folder in which we have maths.go. They are also using the article that we just read, math.go. Inside math.go, we are saying that it is part of the utils package. Okay, okay. Rules folder name equal package name usually, but it doesn't have to. File starts with package this, and this is capital A, so that it is like importable. Create the executable entry point. Executable cmd inside cmd app main.go. Okay, import github slash my name. Shit, okay, that is crazy. Note the import path. This path comes directly from what is in your go module. Okay, shit. Just 1 minute. I will be right back. I have to go to the washroom. 1 minute. Wait. And yep, we totally back. Yes, you can look the go mod file of bubble tea. Okay, to see how the R module name is initialized to Go, open the Go module file of the root. You can add third dependencies using third-party dependencies which are not in our current module, like this go get this thing, and the rest would be done by Go itself. Most of the time it either goes to the official website or the GitHub to download the package locally, so that when we are building we get the thing after downloading. Okay, this thing, this path comes directly input Go module path. Go does not import using relative path like Python or JSON. It imports using this module path slash directory. Your module path came from go mod init. Okay, this is my module path. Okay, so utils lives at this thing. Okay, my module path is Redis go. Module path is Redis go, and we can remove this. This is not a different module. Okay, helper in our main function Redis go slash helper imported and not use handler, undefined handler. Yes, I guess because yo, let's go. Okay, okay, this makes sense. This makes sense. This makes sense. This is the path for our module, and why would they name their module path like this? Build and run. When we build and run, this works just fine. Quick mental model, module, top level stuff. Inside module, we have different packages. Each package has its own directory, and we import packages relative to the module path. And the module path, why would they give such a strange module path? Is this the industry practice? It is such a strange module path. I guess they give this because this makes it unique. Yes, it looks strange at first, but it is absolutely the industry standard. Looks long answer. The real reasoning here is why the whole industry uses weird path like that. This, okay? Why Go uses these strange models? Go wants your import path to be globally unique. Globally, in the sense, like where is it even looking? If I write import this, Go can guarantee that path maps to a unique repository on the internet. Shit. 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 Unique repository on the internet. Okay. This goes distributed package. This is goes distributed package registry. We can go on there and look for packages, and they would have these names, these crazy names. And when we do import some external package, uh, registry, go module registry, or you said I can go to the mod files of bubbles t. That is something. Shit, not this. No. Golang, their GitHub. Okay, they have tutorials, something. Okay, then they have go.mod. Okay, and this is the name, github.com slash the name and thing. Okay, and the version of Go is this. Require all of these packages, this package version this package version this, all of these things, and these packages and these versions, and these are indirect and these are direct. They belong to this guy only, and these are indirect, they are from outside something. Okay, okay, and they also have this go.sum folder, which is something. Okay, and then where is some t in it? Okay, this whole file is part of the t package. If you go to any go file here, it is part of the t package, because this is in the same directory, so all of them are part of the same package. Right, makes sense. And here we have a different module inside this, and the name of this module is tutorial. Okay, requires the main thing, and now this is requiring it externally at module level, because they have created this separate module of its own. And this is something, replace this by this. Okay, and examples. Okay, inside examples we have a lot of files, and this is a package of its own named examples. Okay, and we do not have a main file, so this is a library, I assume. Okay, this might have library or not. Go main.go, this thing. Okay, this is a executable inside this example where we are importing stuff. T. Okay, we are importing this thing as T. Okay, that is cool. That is cool, and that does make sense. Okay, okay. We have packages. We have modules which internally have packages. Each directory can have a single package. Yo, this is Go stuff. And read Go mod file of root. Go mod file of root. What is the name? Bubble tea. Bubble Golang. And yes, we are building Redis in Go, Mr. Darsh Parik. Hmm. Go.mod. Yes, this has these things. Okay, and this has all of these things. This thing makes sense. This is the name of the module. This is the version of the Go that we are using. And this require. What is the require doing? In a go.mod file, what does the require does this thing? So answer require lists the modules your lists the modules not packages, modules the Go code depends on, along with the exact versions of Go version Go uses. So these versions are Go versions, not versions of the modules which we are using. Go does not have a version 2. And then nothing mystical, it is just Go being strict and honest about what your project needs to compile. Now the deeper explanation. Why require actually does what it actually does. Think of go.mod as Go's contract with the universe. The require block says, to build this module I need these other modules exactly as at these versions. No hand waving, or maybe it works, maybe it doesn't. Okay, let's, okay, we can even add a new module right now. The module name, that is how you name module you are making in Go to make it globally unique. That is the convention. You need to write the full path of where the code is hosted to make it unique, because I think that will act, the name of the module will act as a key, and if, and we want it to be unique so that when someone imports this thing, this key will be unique and they will get our exact package. And wherever the Go registry is, if our name clashes, then we won't be able to upload onto the Go registry. So to make this unique, they give these names. And that is just a hypothesis. Go mod build, tidy, Go maintains or go.mode in two ways: require and, okay, it puts dependencies and requires. These are packages you imported somewhere in your code. This may also add additional indirect. These are dependencies needed by our dependencies. Should, why do I have to take care of the dependencies needed by my dependencies? They should take care of them themselves. Go on then. Go then verifies. I think yeah, the second thing, go add. Can we add a module by using the go command, so that go would add the module, like go would update the go.mod file and also add the indirect dependencies for the module, and also download the source file from the Go registry. Version validation, go.sum gives the exact version to ensure no one tampered with the code. Okay, the require block is essentially your dependency manifest. Okay, like this. Go get you did say go. Okay, again remove it, share. Even though this is not moderated anymore longer. Go get this thing and the rest will be done by Go itself. Let's get this module. Go, not in helper. I think this should also work in helper. This would go back the directory, up the directory hierarchy and find go.mod file. Go get. Okay, nothing is happening. It is happening. We are downloading stuff. Okay, we don't have anything here. We don't have anything here with some. This is telling us things and helper ignore. So where are the things then? Should, did go get these in, okay, all of these are required indirectly because we are not using them. Where does download get downloads remote modules? Modules may be downloaded directly from the version control repositories from proxy. A module is defined by the module path, which is declared in a go.mod file. Go modules download directly from the version control repositories may be downloaded directly from a module is defined by a path module name, which is declared in go.mod file together with information about the goes modules dependencies, the module directory, the module root directory is the directory that contains the Go fetched directly from the VCS server or via an intermediary proxy, not how version control server. Go what is the difference? Go mod download does not add new requirements or updates. Okay, that makes sense. Uh, yes. Okay. Okay. The part that makes sense is we have a module. Yes. To summarize, we have a Go module that is too small. We have a Go module, and that module has packages, and these packages can be multiple executable. Yeah, multiple binaries, and we can have multiple libraries. Okay, that also makes sense. Should this libraries is a part of this whole thing? That is crazy. Yeah, packages have libraries and binaries, and when we want, and yes, the name for the module is kind of strange, and it has, we generally default it to where the module is hosted because that makes the name of the module unique. And when we actually host our module to some Go repository from where Go get downloads our module, our name will not clash. Okay. Module name unique, and there is the Go module name has to be unique because this the Go module name has to be unique because when we host it on the Go, when we host it on the Go registry, it doesn't clash with any other module, and when we do Go get module name, we don't we not we go goes to the registry and find the module. Short answer, yes, the module path must be globally unique, but the reason is deeper than the registry might clash. Go's entire module system is built on the assumption that the module's path is the canonical identity of your code. Okay, why Go module names must be unique? Go module is identified by its module path. Yes, module path. My cool library. Yes. That string is not just a name, it is the global ID for my whole module. Global ID, global as in the sense of the whole universe. Shit. The sound is not working in my Linux. Lol. Oh, wait till I correct this. Shit. Sound is not working on your side. Here it seems to be cool. Shit. Linux problems. Drivers not working. Camera does not never works on Linux. Okay, global identity. So Go treats this path as a coordinate that points to exactly one place in the whole universe where my code lives. So if someone else makes the same thing, Well, that is impossible unless they own your GitHub namespace. That is the entire point. How does Go module resolve? Okay, that is the entire point. The domain URL guarantees uniqueness. When I run this, Go does parse module path, check if path uses a recognizable hosting service pattern. Okay, the Go registry. Okay, okay. If yes, fetch from GitHub. If yes, fetch from GitHub, GitLab, Gitbucket, or fetch from Go proxy, Golang, this thing. Verify module integrity using go.sum. Note the important thing. Go proxy does not host modules in the sense of namespacing like npm or pip. They simply cache modules fetched from their original source. No central repository. The repository URL itself ensures uniqueness. Okay. So Go tries to figure out from the name of the module where it might be hosted, and if it is unable to find, and Go goes for looking at the proxy Golang server, and if nothing is there, Go get my package very unique. Malinformed path missing dot in the first path name. Okay. Okay, so this is more than just a convention. The Go compiler actively expects it started working. Bro rewrote the whole writer driver in Rust. So this is more than just a convention to put the URL as the module name. This is more like the Go compiler expects you to do this. Okay, hello.com slash this. It is looking at hello.com to look for the package unrecognizable import. Reading hello.com, my package unique, go get 404 not found. Okay, the package therefore should, the module name should therefore give an indication where it is being hosted. So that is cool. Okay, okay, okay. And if yes, if it's from GitHub GitLab, okay, it must be unique because Go's module resolution works like this. Module path maps directly to a repo location, and in this thing hello.com, I just said hello.com slash my package very unique, hello.com my package unique question mark go get equals 1 for a normal website like hello.com. But if I were to say this is on github.com, github.com slash, let's say, my name and slash a package which does not exist, then it is looking for it. And now the error is different because back here this was a generic website which I guess the compiler thought might be hosting a Go package and said go get me stuff, but 404. But here we are giving a GitHub path and module this get ls remote my package unique and Go package mod caches VCS shit, that is crazy. That is, so GitHub has an integration. What is this? Uh, what is this URL? In slash user slash Jatin slash Go package mod. Okay, why was Go looking locally? It was looking locally, and then this thing not found. Okay, I guess that is the main thing. When remotely Go was looking, repository not found. And Go was also looking locally for the package. Maybe I have the package installed locally. Okay, okay. So Go is smart. Go is smart. Whenever we get some module from the internet, Go looks at the path and tries to figure out where this thing might be. Okay, and then go downloads the thing, and we want this to be unique, and okay, that's cool, and also indicate where the thing is hosted. Okay, that's cool, that's cool. Then when I do go get where are the things, where is the module imported, where is the module downloaded. Let's keep it clean. Where does go module, put module, go get module does not download modules in your project folder. Instead, go stores all modules in a global module cache located here. Go package mod here. So if I were, we do have package modules, cache, VCS, github.com modules from GitHub. The one that we just downloaded was this one, Bubble. And should we have literally the whole repository, it seems. Okay, okay, that is cool. That is cool and makes sense. And let's say I have written a package locally and I want to put that package in my local go, not package, module. I have written a module locally and now I want to put that module in my slash uh, home slash go directory so that any local go module can import it. Shit, this is crazy. I can use this facility. I can literally use this and I don't have to. No, shit. I thought I can use this for competitive programming and do not have the boilerplate code in my main file where I'm solving the competitive programming question, because I can import that external package and use it here. But that does not work. That does not work because I will have to send the solution onto Codeforces, and Codeforces would not have that file, that module that I'm importing. Yeah, it is. Yep, that is what I trying to explain, but this YouTube shit doesn't let me shit. You can try importing one of the package and using it. Yes, and to import it, we have to give the module name slash package. That is cool. That is cool. That makes sense. Like, shit, that actually makes sense. Like, a lot of things are clearer now. Use the go get command to get the module and use the same path to import it too. Yes. You can even use an alias if the name is too long. Yes. And let me not read the rest of the thing that you said. I think I know how to do that. T0 and server. I'm importing this. I can import this as H. Shit. Imported H and not used. Yes. Yes, like this. Yeah, that is cool. If the name is too big, then we can do this. Inside the file you are importing, not the module. You can even, inside the file you are importing, not the module itself. Yes. You can import one of my library. It is a small library, might be good for testing. Yes, yeah, yes, give me your, but you cannot send the link. Shit. Just give me your GitHub URL, not just GitHub username. If you haven't sent it before at some point in the past. Optional. Give your module a proper module name and keep it in a repo. This is how real modules work. module name, then import it locally. Okay, option 2, use replace for local developers. Okay, we can even use this. What does not work? Let's okay, I will import your I tried sending my GitHub username twice. Shit, it is same as my YouTube name with just dash 15 instead of 015. Okay, Archit Mishra, CHIT Mishra hyphen 015. Okay, let's go. Shit, is this you? I think 43 repositories. This might be you. Go. Which one should I import? You have some MIT license stuff. Olang in C++. You have done stuff. Let's wait. 100 contributions. Where do I see like which languages you have worked with? The share you have worked with all of these things. Shell, Java, Vue, TypeScript, Python, Dart, what the hell? Lua makes sense. Yeah, C makes sense. HTML, Go, C++. It is crazy, and you have done quite a few things in Go. Go tables. Go tables, this one. Okay, documentation is amazing. A helper module written for prioritizing speed and small size. Okay, and what I will do is I want to do this like crazy thing, which I think is crazy. Uh, Go module stuff and okay, my code. Inside my code, I will create a Go module, and the name would be main code. Let's just say the name of this thing is main code. I'll go back here. I just have my module and git clone github.com https colon slash slash github.com slash Archit Mishra 15 go. Is that the name? Nope. Mm, shit, I messed up the name. My bad. Yes, we have this here locally. cd my code and go dot mod go dot mod and here require in this the name of the module. Go dot mod name is just this. Go tables. Okay. Uh, slash with Mishra 15 slash go tables and require path. Okay, they also need the path, the version. The version would be 1 point. How do I say the version? V 1.24 to 4.7. Okay, that is nice. And now we will use replace. Replace this same thing with replace this with a local path. How do you use the replace command? With a local path or yes, with a local path. Path ending at the dot mod file. Yeah. Slash documents programming. Nope. Yes, programming stuff and go modules, go tables. Okay. What is the error? Syntax. Syntax is okay. We don't use the braces. Yeah. Substitute these with nothing in globally. Require this. Syntax replace module without version must be a directory rooted starting with this or this. Why? Yes. Why we cannot do this as a global repo as a read-only cache? We have to start from the root or from dot dot. Okay, let's use dot dot syntax. That should that does work. Okay, that does work. That does work. I think that does look cool. Go tables, and so I thought using a separate mod MD to later render it as HTML might be easier. Huh? I wanted to test. Like it would be easy to use go get. It would go in the main uh, home slash go directory. Rest would be done by go itself. And instead of writing import each time, you can write it using this to include multiple. Yes, see how I am importing something like, yes, that would make sense. Why you edit mod files when you can do it in the main code file while importing itself as the docs for vulnerability. They are doing it like they are aliasing ty followed by the URL and remove the comment from in between. Shit, here this part is telling me that like do not look for this thing at like internet on the internet. The thing is here. Okay, the thing is here. The thing is here. And now I will be able to use your code. New file, main.go, and here package main. Why main? I'm just calling this package main. Uh, you can call this anything we want. Main packages are executable. We want to execute this, so cool. Shit, is your thing also executable or does it also have libraries? Table.go. Okay, it is a library, so that is cool. Some functions. Okay, shit. A reference to a function. Okay, default buff pool and print style displays all available things. Prints creates a style. Okay, you defined a structure and then you started a new scope here, and this is okay, shit, this is okay, makes sense. This is a list or array or slice to be more exact. This is a slice of a structure and this is the type of the structure that this slice has. And in here you are saying these are all the elements. This is the last element in that slice, this is the second last, and stuff like that. And then for I, index, info, ranges, styles, range styles, the styles that you specified here, you're going through the styles, then printing them and creating a sample table from new string. Okay, and then printing stuff. Okay. Adding row and then printing again, like whatever the logic is. Okay, let's call this function print styles. And I should be able to import your package with the name, the module name, github.com/ shit, go tables, and we will call this as gt dot print styles function. Let's go. Shit, let's go. This is working. Let's go run this and no errors. Let's go. Shit, literally, let's go. No pun intended. Think of writing a separate website which would contain the docs. Ah, that makes sense. That makes sense. And main portfolio website. Shit, I also have to build a portfolio website. You don't need to bother with that, at least for now. Just simple. Get it. This is cool, and you have a lot of instance in this thing. Okay, so we can import modules externally from Go. That is cool. That is cool. That is cool. That is cool. Go, and you have all of these functions. Shit. What is this doing? Info. Yeah. Not enough arguments. It requires some arguments. Text. Go to definition. Go to definition. Literally go to definition. Shit, this is very well written. With comments and everything. I've not written anything like this. Is print the text with blue. Ah, if you want to print information, then use this. For success, use this, which prints color in this format. Okay. Warning and error. Okay. Info success warning error. Print info. Print. This is info. Gh dot success is success, and then gh dot warning. This is warning, and gh dot warning, and what was the other thing? Error. Error. This is go run dot. Shit, I guess I messed up somewhere in the API. I didn't read the documentation correctly. May not go. This is calling a sprint. A sprint is your own implementation. That is cool. Colorize function, and this is very cool. This is very cool. Okay, okay. We know how to import modules. That is cool. Okay, that is cleared up. We know how to import modules. Git status and go.mod. We added quite a lot of stuff in here. We can just delete it. Ls and yeah, well, git reset hard. Shit, git add. These files are untracked. I also want to delete them. How to git reset hard and remove untracked files. It doesn't remove untracked files by default. Two-step process. Okay, first do this, then git clean fd force and clean. Git clean requires a force option to actually delete files, and the flag instructs git clean to also remove untracked files, and git clean removes all the objects which are not being used. Okay, fd force and untracked. Cool. Main.go. Yeah, we can improve the structure later. Right now we'll just write stuff. Okay, in main func main we have the main function, and in this let's have a listener ls or ln, whatever, error equals net dot, I want a listening socket for a TCP connection, and the port is this. Yes, also why do we have to give the address? That is one thing. Yes, net. Why do we have to give the address? That is also one thing I would get to know. And I feel very good that I understand all of this import things here. That actually feels very good. Huh? We get off the stream. I do not misbehave here on the stream. Okay, you don't need to bother with that, at least for now. I created a simple CLI calendar using this library in Go. Shit. Okay, I guess I would have to go. It just remains string, you are prompting it. Okay, it just remains a string. Okay, I will have to read the documentation, what you're doing. Second time, I guess. This is more for learning Go than for learning how Redis is. You can try it to automatically remove unused libraries, FTX. And but would it, like, if wherever, if I am in a Go repository, Go module, and I run this command, go mod tidy, all the modules which I am not using current in the current module, will they be removed? Because I might be using those modules in some other Go module, right? Yeah. And anyways, I guess I would have to go. I have to go. I have a birthday party to go to. Yep. And that would be it for today. We learned about modules, and that was pretty cool. And I want to understand, why do we have to give in the address plus the port? Port makes sense. Port makes sense, but why do we have to give the address? We will learn that in the next episode. Yes, party. A friend of mine, like, somehow has his birthday today, or maybe a couple of days ago. I don't know. I just, yeah, there is a party. Yep. And that would be it for today. And thank you for being here. Bye.